Okay. Hello, everybody. Good morning, afternoon, or evening, depending upon where you're listening in from. This is your host, Jennifer Brennan. I'd like to welcome you to the NASA Earthdata webinar, Explore, Discover, and Use Field Campaign and Related Data. As most of you have noticed, we do have two optional polls located at the bottom left and middle of your page. We do appreciate your feedback on these polls. I have 2 p.m. Eastern Time, so we'd like to go ahead and get started. First, what I'll do is I'll go over some housekeeping items related to this webinar. To ensure best audio experience, the conference has been placed in silent mode. However, if you have any questions or issues, what I'd like for you to do is enter those into the Q&A pod. And again, that's located in the lower right-hand corner of your screen. It works like a chat. Okay? The webinar will be recorded and posted not only to our Earthdata Adobe Connect catalog, but also to our NASA Earthdata YouTube channel. And I will provide the URL to you at the end. All presentation files will also be available for download at the end of the webinar. As far as timing is concerned, this webinar is 1 hour long. We've allocated 45 minutes to the presentation and demonstration, and then we'll use another 15 minutes for the question and answer period. After our speaker has finished his presentation, what we'll do then is we'll move to the final set of polling questions. The question and answer period will follow directly after the final set of polling questions. So be sure to stay in the room and/or stay on the line to participate. Okay, as I mentioned earlier, you will have an opportunity to ask your questions throughout all portions of the webinar, with the exception of the demo using the Q&A pod. But we will take all questions at the end. We will not be using the raising hand function. It has been disabled. We'll take the questions when we're finished. One final note, depending upon the volume of questions that are received, we will extend the Q&A period an additional 15 minutes to 3:15 p.m. Eastern Time for those of you who may wish to stay on the line. So what I'd like to do now is move to our agenda. Make sure that pulls up here first. The first 15 minutes or so will be dedicated to an overview of the NASA Global Hydrology Resource Center Distributed Active Archive Center, or GHRC DAAC, and also will provide an overview for the Field Campaign Information Explorer tool. We will then transition to a demonstration of this tool where our speaker will showcase key features and functionality as he shows you how to find data and related information from the NASA Hurricane and Severe Storm Sentinel mission. With that, it is my pleasure to introduce today's speaker, Manil Maskey, who is a data scientist and systems architect at the NASA GHRC DAAC. Manil?
Thank you, Jennifer, and thank you all the attendees. Like Jennifer mentioned, today I'm going to talk to you about a field campaign tool that we here at GHRC have been developing. The tool that allows you to explore and eventually discover a field campaign and related information about that field campaign. The tool discussion will be focused mainly on the most recent hurricane mission, the HS3. So all the demo and everything will be related, focused around that particular mission. Of course, before I begin, I would like to acknowledge all the people who have contributed to development of this tool. That includes software developers, data management team, and also a few grad students. And also the HS3 science team who have provided us with helpful feedback regarding data formats and conventions. Next few slides, I would like to give a little bit of background on Global Hydrology Resource Center, also known as GHRC. GHRC is one of NASA's Earth Observing System data and information systems 12 archives. 12 Distributed Active Archive Center, also known as DAACs. As you know, each DAAC provides its own set of expertise in particular science discipline. GHRC's mission is to provide comprehensive active archive of data with focus on hazardous weather and science related to the hazardous weather. In addition, GHRC also provides knowledge augmentation services for such data. In terms of data that GHRC serves, GHRC is recognized as the National Lightning Archive. GHRC has been ingesting, archiving, and generating products and distributing lightning data mainly from TRIM lists since 1998. And other ancillary data sets such as from the National Lightning Detection Network is also being served. As you can see, GHRC also serves passive microwave data. From the timeline you see there, GHRC, along with its predecessor program, have been ingesting, archiving, and distributing passive microwave data sets for over 35 years. GHRC also has a long history of not only providing support during field campaigns, but also ingesting, archiving, and again distributing science data and other field campaign related information. Although of episodic nature, GHRC processes are in place to handle such field campaign data sets along with other satellite data sets as well. The two main types of field campaigns that GHRC is involved with are the precipitation measurement and validation missions and the hurricane science study missions. And one of the hurricane study mission is the HS3, which stands for Hurricane and Severe Storm Sentinel, and my talk today will be based on that particular mission. So I want to give a little bit of information about the mission itself. Stands for Hurricane and Severe Storm Sentinel, like I said. The objective of this mission is to measure environmental and inner core processes that lead to storm formation and intensification into major hurricanes. It is a multi-year mission with flights over 9 named hurricanes. The deployments were during the hurricane season of 2012 through 2014. The GHRC is responsible for building the data system for this mission, the planning for which began around early 2014. The data users that we envision from this HS3 mission is, of course, the SS3 science team, the NASA's Hurricane Science Research Program, the operational users at NHC, National Hurricane Center, and of course the larger hurricane science community. Now to the science question that the mission is trying to answer, it's mainly twofold. Environmental factors, the questions related to those are, what impact does the Saharan air layer have on hurricane intensity change? How do storms interact with shear produced by large-scale wind systems? How does the outflow layer interact with the environment? And the other side of the science question is actually studying the inner core of the hurricanes themselves. And the questions are, what is the role of deep convective towers in intensity change? Are they critical to the intensification? What changes in the storm structure occur prior to and during the genesis and rapid intensification? And also, how do intrusions of dry air impact intensity change? To answer these questions, HS3 had 6 different instruments deployed for environmental payload. It had SHIS, the AVAPS, and the CPL. For studying the inner core of the storm, it had HIRAP, HIRAD, and HEMSR instruments. GHRC now has data from 5 of these instruments, I believe, and in most cases for the entire mission. Furthermore, GHRC has also collected and ingested and archived the worldwide lightning location network data sets that are centered around this mission. So that gives us some additional data for this particular mission. The data system that GHRC is developing includes several components. The system allows users to discover data using traditional search and discover mechanism, and also allows them to visualize the data. In addition, users can first explore the available data and then narrow down the data for further study. The HS3 data that GHRC is ingesting includes not only science data, it also includes the browse images, which are sometimes provided by the data providers themselves, but in some cases we generate them as well. The data also includes flight reports, the flight track information, and I want to highlight the fact that science data were required to be in netdata format given to us by the provider. And we've gone back and forth with data providers to make it CF compliant as well. So having such a standard format had allowed us to provide many of the features for the Field Campaign Information Explorer, including developing a set of APIs and libraries to use the data. The Field Campaign Information Explorer itself is a web-based tool and is also designed to be compatible with future field campaigns. So the motivation to develop this tool is that many field campaigns have a certain period around some event when all the mission instruments are properly collecting the data, and in general the data collected is able to address the science objective. And we call that the golden cases of the field campaign. The intention is that the data for these golden cases can be used to study additional use cases. We think that information-rich contents present in the flight reports, which includes images, annotations, and other platform instrument information, and also information from other data sources that can help users identify such golden cases. Also recently, GHRC is focusing on providing data based on earth science events, as evident from some of our recent data publications, such as the tropical cyclone precipitation feature, TRIM-based data for cyclones, and also the woolen lightning data subset for HS3 hurricanes. We think that this tool can be a complementary tool in developing such event-driven database. Now moving on to the actual tool, which is called the Field Campaign Information Explorer. The feature includes an overview of past storm events with all of its attributes that are collected. And if it's an interesting storm, a user can drill down to a particular storm. They can, if there was a mission for that particular storm, they can reenact the mission. They can explore all the contents of the report. And they can also get the data based on the flight segments. They can also visualize the data for certain segments of the flights, and eventually we want to lead them to the part of the data where they can these golden cases of data. So this is an example of a couple of pages of a flight report for HS3 mission for Hurricane Ingrid, I think. As you can see, information present in this report, you have images, you have annotations, you have information from other data sources. So there's a lot of relevant information about the mission that have been captured in these flight reports. So at first, we developed a tool to extract and ingest the information from the reports into a database. So we had people going through each of these. I believe there were 43 flight reports for HS3, and ingested them into ingested the information. By doing so, it allowed us to create a set of services which can be queried for information for a particular hurricane and mission. And Field Campaign Information Explorer is just one of those tools that uses this service. Like I mentioned earlier, we have the storm overview feature that allows users to interactively explore at a high level and look at historical hurricanes and some of their characteristics. To achieve that, we have ingested all the data from Earthdata and created a set of services to develop this feature. And we provide information visualization tools to explore multiple attributes of the collected data. For example, we can plot pressure, wind speed, the duration, and the location, all that, and temporally as well. So this provides a summary statistics of the hurricanes, past hurricanes, and the detailed information can be explored using the tool. The plotting and previewing service is part of the detailed page where on-the-fly subset of the data is performed. This subset can be quickly plotted using a set of data set specific data recipes that we have developed. The plotting or visualization, mainly visualization, are performed based on our own literature survey. We went through a number of papers that refer to the HS3 data sets and created a list of most popular fields for each data set and their corresponding visualization methods. Then we implemented those visualization with using OpenDAAC as our data subsetting mechanism. In this case, having the data and services co-located at GHRC helped us because the performance there was no performance hit because the service could access the data locally. So the way a user would perform these subsetting and plotting services by selecting the points along the flight track and specifying their start and end point. So this is how everything comes together. Basically, you have on the left-hand side all the components that are part of the data systems. All the information is cataloged and served via services, which allows other clients, not just the Field Campaign Information Explorer, to query for the information. For the information, the Field Campaign Information Explorer, we also bring in background imageries for context, to provide a context from Global Imagery Browse Services, also known as GIBS. Now I would like to proceed to the demo. I also would like to point out that the system is in a development environment right now, and we hope to have an alpha version out for testing sometime in spring. And we'll probably send out a note to the scientists to give us some feedback after they get to play.
Okay.
So let me start the demo. Okay, this is the initial screen that you see. Like I said, this is an overview of past hurricanes that you can see. And what it's showing is plotting wind speed, average wind speed against average pressure. Here the size of the circle indicates the storm, how long the storm lasted, and of course the colors mean the categories, maximum categories that they sustained. You can go directly to the Information Explorer if you don't want to look at a particular hurricane, but I would like to show you some of the characteristics here. You can see a detailed information about a particular hurricane if you hover around. And you can also change the year to see the annual hurricanes for each year. You can change the axis as well. And if you really want to go into detail, you can click on a particular hurricane and it will take you to the detailed page. So it's loading all the information for that particular hurricane from the report. So let me pause it here. It is paused, right? So on the right-hand side, what you see is the information, ancillary images. These are information extracted from the hurricane flight report. As you can see, one of them is highlighted. These are all temporarily tagged. So let me load it first. So depending on where the plane is, these will be highlighted. So you know temporarily which the images are tagged for which particular part of the flight. By default, we have the hamster reflectivity displayed here, and that's configurable. You can change that to any of the field or data sets that you like. As you can see, you can change the year from here and go to a different hurricane and look at if there are multiple missions. And if you have multiple flights, you can select from that list. For this, you only had one, so you only see one. These buttons allow you to interact with some of the features. This is the 2D view, top-down view. You can change it to the side view, which is basically the three-dimensional view of the interface. And this allows you to take snapshots, and you can also subset the data, which I'll show in detail later. So all of these images have annotations, so you can hover around and look at in detail the annotations for it, or you can bring it up and in a zoomed view and look at and slide through each one of these as well. And you can also look through the browse images for this particular flight. Looks like we have IRAP browse images for, and this in particular was provided by the data provider themselves. The legends about what is being shown on the user. You also see the storm track here at the bottom with the red line displayed as well. So the important part here is the data tab. As you can see, these are all the data that matches the GHRC holding for this particular time frame. And you can data set, and you can click that, expand it, and look at the granules. So in this case, you have hamster, and it will ask you, since you are trying to download the data, it will ask you for your URS authentication. And once you provide that, it will start downloading the file. As you can see, this is like 448 megabytes of data file, so I'm not going to download it, but the idea here is that we don't want users to download the entire file. We want them to be able to narrow down to the interesting part of the of this particular flight and be able to subset that data for that particular part. So this is now I changed the view to a side view, so you can see and you can increase the speed of the animation so that the planes move faster, and you can skip over certain parts of the flights if you think it's uninteresting. Things like getting to the hurricane and coming back from the hurricane, you probably don't want to have a slower speed. So the three-dimensional view is the way we have done it is we're creating a small slices of images on taking a vertical profile from this is in particular is hamster data reflectivity, and we're putting it as the plane moves along. We're placing them right on the location of the plane. So let me move this a little bit faster, I guess. So the reason I'm animating is I want to get to a certain part here to show you a feature where you can stop and take a snapshot of it if you wanted to share some of the interesting part with others. Say if I wanted to stop there and take a snapshot, right? So what this allows you to do is take a snapshot of just the map part and look at it and share it with others as well. Now this, now I'm moved back to the 2D view because I wanted to show you a feature for subsetting the data based on the flight track. So this button allows you to bring up this interface where you can subset the data. So right now, I'm clicking on the flight tracks here to get the start and end point. Any 2 points will do. But let's say I want to subset this part. So it'll collect the time and date and location from it. And currently you have these 4 options because we only have those data right now. So if I wanted to plot high-RAP reflectivity for this particular location, you can do that. And it will give you a snapshot of, it'll use OpenDAP and backend services to generate these images. Let's say if I wanted to preview what the data actually looks like in the text. So this is for Hampshire precipitable water vapor. I can look at that instantly. Then if everything there is what I like, then I can actually download the data. And now the same data file, that 448 megabyte, now is just 4 or 5 megabytes now. Only the subsetted part, subsetted temporarily, and also using the parameter that you wanted to see. Now, if you want to look at the actual flight report itself, then you can also do that because the entire interface is based on the flight report. And you can see all the information that we extract from the flight report is in here. And look at that, 32 pages of flight report, and we have already extracted out all the information and put it in our information system. Now, one thing I wanted to show is the bottom time bar. You can also use that to navigate the flight, and the corresponding information on the right-hand side changes based on that because the plane, it's all based on the location of the plane. As you see, when I cross the date, the background image is also changed because the GIBS imagery is a daily image. So we access that image based on the date and time of where the plane is. I believe that's the end of my demo. With that, I would like to pass it back to Jennifer.
Okay, thank you, Manil. Thanks, everybody. So what we're going to do now is we're going to move to our final set of polling questions. And I'll give these questions about 3 minutes or so. And then after that, we'll move to the Q&A portion of the webinar. So if you had asked a question earlier in the Q&A pod, that information has still been captured. We'll see it when we transition to the Q&A session, which will follow directly. Okay? So be sure to stay in the room and or stay on the line to participate. All right, thanks. Okay, we'll give these questions just about another minute or so, and then we will move directly to the question and answer period. Okay, everybody, we are going to move to the question and answer period. But if you do have feedback, particularly regarding the additional feature wish list that you'd like to bring up during the question and answer period, please feel free to do so. So I'm just taking a look at the list right now, and there are currently no questions. So go ahead and if you have a question, type that into the Q&A pod, and I will have our speaker address those questions. And while we're waiting, I did want to tell everybody that we do have a NASA Earthdata YouTube channel where there are, I think there are 55 or 56 data discovery and data access webinars that are currently hosted there that span the disciplines for all 12 of NASA's EOS DAACs, if you're interested in checking those out. Okay, fantastic. So the first question, Manil, is, are there plans to expand this to other field campaign data sets?
The answer is yes. We started with HS3 because that was the ongoing mission at that time, and that was multi-year mission, so that gave us some time to develop this while the mission was going on and have it ready after the mission was complete and all the data sets were. But like I showed the components architecture there, it is quite flexible to adapt to any future field campaigns, and it doesn't have to be an airborne field campaign either. So.
Okay, thank you, Manil. The next question, it's really a combined comment and question. It looks like the images that are available, such as satellite images, are taken from the flight reports. There is usually context provided in the text of the report for the images, so isn't that, quote, lost in translation, end quote?
I believe I showed that in demo. Each image has annotations. Those are also saved, and maybe the viewer missed it. There are, for each satellite images, there are time, and the temporal information is either part of the image or part of the text, but we extract that and actually put it in the database. Plus the annotations or captions, we're also saving that. If you hover over, you see that information as well, or you can look at in detail as well. So I can, I don't know how to show that again, but I can certainly go over that again if needed.
Scott, would you like us to go back to the demo recording? If you want to type into the Q&A pod, Dr. Braun, if you'd like for us to go back to the recording. Okay. All right, so let's move on to the next question. Can this webinar, at least the demo portion, be posted on the GHRC website so it can be used as a reference or help video?
Sure. I'll ask our web folks to put it over there.
And just as a follow-on to that, the entire webinar will be available not only on the NASA Earthdata YouTube channel, but also posted to the tiny URL. It's our online Adobe Connect webinar catalog. You'll be able to find the recording under the 2016 webinars within a couple of days. All right, and then the next question is, let's see, related to our, oh, okay. So getting back to the previous question, Dr. Braun wanted to know if more than time and basic details were available. For example, often there were comments related to what was going on at the time during the flight.
Oh, okay. I will have to go back and see. Probably not. I think we're extracting just information about the multimedia information there and its the annotations that are part of that multimedia. So.
But this is certainly something, Manil, that you could contact with Dr. Braun offline about. Perhaps the two of you could converse.
Right.
Be helpful, I think. Okay, the next question, and thank you for the questions and comments, by the way. The next question is, could users submit or upload to their own, upload their own data for visualization and analysis?
So currently, no, because our system is tied to the GHRC and the CMR system. So the list of data that you saw on the data tab is actually making a query to CMR to get all the relevant data for that particular time and space. So if your data is in CMR, then it will show up. If not, then currently we don't have a mechanism to add data that's not in the SDIS yet.
And for those of you who may not know what that means, CMR stands for Common Metadata Repository, and that's essentially like the back end for the NASA Earthdata search tool, which can be found at earthdata.nasa.gov. All right, and the next question is, do you have any materials to promote these tools to students and educators at the secondary school level?
I don't believe we have it currently, but we can certainly, our outreach people here are probably listening as well. They can, I can connect Margaret Roberts to them. Maybe making it specific to the students. Is this about learning? I'm asking the question here. Is this about teaching them about the hurricane or science missions?
So Mary, did you care to clarify further? So I'm thinking that what you're asking for is whether or not there are any kind of handouts or online tutorials that provide information about the tool, what its key features and functionalities are, and how one, appropriate, relevant URLs, and how one might go about using these types of tools. Have I accurately assessed what you're asking?
Yeah.
So Mary, if that's kind of what you're wanting to know, I would be happy to follow up. Okay. Yes, I would be happy to follow up with you offline with some links to a number of different resources. And I'm sure once this tool, is out of development mode and, released publicly, that there will be information about how to use it. But in the meanwhile, I can certainly get you started with a number of wonderful NASA Earth Science teaching resources. Okay, so I'll follow up with you offline. And let's move next to the following question. The next question is, you're welcome, Mary. The next question is, do you provide the satellite data that are co-located with the airborne observations?
So, like I said earlier, if the satellite data is served through CMR, if there's a metadata for that particular satellite in CMR, yeah, it will appear on that data tab. But actually visualizing those data that capability is not there yet. this is Svetla, right? So I know Svetla's interface does that right now. So answer is currently no. If it will show the data, but that's the extent if it is in as is CMR.
Okay, thank you, Manil. The next question is video from the Global Hawk cameras available?
No. I don't know where those videos are archived. That's a good resources to have, actually. If Bjorn can provide us with some link, that'd be great.
Okay, great. Thank you, Manil.
They might be, this is Michael Goodman, I'm taking a guess they might be at ESPO. You might want to check with, Marilyn Vasquez or Bernie.
Okay.
They usually, archive a lot of that stuff.
Okay.
Okay, thank you. So I'm not sure if I know what this refers to, Mohammed, so you may need to clarify this a bit, but your comment is, I think it is really important to have this, not important to be visualized, but some missions were done just for that. So I'm not sure what this refers to, unless I'm missing something here. If you could please elaborate. Oh, okay. You were talking about the satellite flight data that was mentioned just previously. I gotcha. Thank you.
Right. So answer is yes. If the data is in the CMR, it will show up. And yeah, we don't have a mechanism to visualize, which may not be important. Right. Mohammed is right.
Okay. Okay. Thank you, Manil. The next, let's see. So the comment is camera feeds are probably at Armstrong. Don't think they're archived by ESPO.
I think Scott is right, because I remember going through ESPO site to look for data before it was being published, and I don't remember seeing camera feeds there. So I will look at Armstrong to see if
Hey, Scott, thanks for correcting me.
Okay, thank you. So right now I'm looking and I don't see additional questions. If any of you have questions, please feel free to enter those into the Q&A pod. And while we're giving that a minute or so, I wanted to point out to everybody that the demo file is available for download, as well as the final presentation below in the file sharing pod. So if you actually left-click on either one of those two file names, you should be prompted with an option to download the file. So what will happen is, if we don't have any further questions, we'll log off from the telecon. But generally what I'll do is I will leave the virtual meeting space open for an additional 10 minutes or so, so that for those of you who might be interested in downloading the files or think of additional questions, those questions can be captured. And certainly our speaker can follow up with you separately offline. Are there any additional questions? From anybody? If there are no additional questions, I would like to thank everybody for joining us today. We actually do have another webinar coming up in a couple of weeks, which will be, a different focus. It'll focus on middleware services at our Land Processes Distributed Active Archive Center in Sioux Falls, South Dakota. And then later in March, we will have a webinar that will focus on a data product or tool from our Atmospheric Science Data Center in Langley, at Langley Research Center. You're quite welcome. We're glad you could join us today. There are no further questions at this point. You're welcome, Mohammed. We will go ahead and log off from the telecon, and I will leave the meeting room open. So please feel free to enter any comments or questions that you might have. And thank you, Scott and Michael, for joining us today. And it's nice to see some of our repeat attendees here in the room again today. All right, everybody. No further questions. I hope to see you at another webinar in the future. All right, thanks, everybody.
Thank you.
All right, bye-bye now.